Dr. Moberly, and I'm going to do a worksheet. It's about to write Dr. Worksheet there. Dr. Moberly. I'm going to do a solution set for this worksheet on the homogeneous Bernoulli problem. Bernoulli starts out as first order homogeneous non-linear. And what we're going to end up with is a homogeneous, non-homogeneous, and linear differential equation after the substitution. So it says, how do we substitute? Well, first we need to recognize this is a very important value. We say that A is equal to minus 2. I think I put an alpha there just to distinguish it from the A. I wasn't quite sure if I could read that on Kresig's text, whether that was supposed to be an A or an alpha. And if U is defined as y to the 1 minus alpha, that's going to be y to the 1 minus minus 2, which is y cubed. Okay, and then if that's what U is, then dx of U is going to be 3y squared y prime. That's chain rule. Let's just remind ourselves what the chain rule is. If we have f of g of x, and we take its derivative, well, that's f prime of g of x times g prime of x. And here the f is the cubing, and the inside is the y function itself. All right, that's our chain rule. So now let's do our substitution. Substitute u and u prime, so that's u prime, into the equation. Well, let's take the original equation, and let's go ahead and multiply it through. Multiply the ODE so that the first term matches this expression, matches the u prime. Say, well, why do I need to do that? Let's take our differential equation, y prime minus 5y, and I'm going to go ahead and switch it around to the standard form. Let's mess that up. E to the minus 2x, y to the minus 2. And then what we're going to do is multiply it by that. 3y squared, 3y squared, 3y squared. It's this negative expression. And now we're going to look for some cancellation simplifications that we can achieve. Let's get this to be u prime. Let's get this to be, oh, look at that, u. That's going to be a minus 15u. And then let's simplify this. Notice the y is going to go away entirely. This is going to be minus 3e to the minus 2x. All right, we now have a non-homogeneous linear first order ODE. Smile, we have a method for doing this. Let's take the integrating factor. Here is our p of x, and the integral of p of x dx is going to be minus 15x. Now we don't have to worry about the constant. Ignore the constant of indefinite integration, because really any constant would still make this an integrating factor. That would just be something we'd multiply by, and we'd multiply by it on the outsides. It just doesn't make any difference what that constant would be. Now we've got h of x is equal to minus 15x. So integrating factor will be e to the minus 15x. And we're going to multiply by the outside. Oh, we've got the solution already. Is going to be e to the positive 15x times integral e to the minus 15x times minus 3 e to the minus 2x dx plus c. Almost got an expression there. It's going to be, let's do the integral first. This is going to be e to the minus 17x times minus 3, which of course is going to be, when we integrate that, we've got e to the minus 17x over minus 17 times that minus 3 plus c e to the plus 15x seems like it should be 18, huh? But it's not. It doesn't change. All right. Yeah, that's it. And I guess we could simplify that a little bit. U of x equals 3 over 17 e to the minus 2x plus c times e to the 15x. Now we need an equation for y. Y is equal to the cube root of u. That's the inverse of this definition here. Y, q equals y3, y equals cube root of u. We're just bringing that down to where we're going to make use of it. And that's going to be equal to the cube root of 317 e to the minus 2x plus c e to the 15x cube rooted. Is there anything else we can do to simplify this? Hard pressed to see. Maybe, nope, it's a cube root of a sum. There's really just no way to simplify that any further. If we had an initial condition y of 0 given, we might say that that's going to be equal to something with the cube root of 3 over 17 times 1 plus c, and would allow us to solve, given an IC, we solve c, and then we'd be able to use y of x with that c in it for a particular solution. Would give us solution. Okay, if we had then we would have a particular solution based on solving for C. All right, I'll stop with that.